Alright, this next chapter we're going to be talking about similarity, similar polygons, similar triangles, that sort of thing. So as kind of an introduction to that, we want to review how to write and simplify ratios and how to solve problems using proportions, and then also want to talk about how to identify similar polygons. So, a ratio. A ratio is a comparison of two numbers by division. There's different ways we can do this. If we have a ratio of two numbers a and b, where b does not equal 0, because we cannot divide by 0, we can write this as a to b, just the words. We can write this as a colon b, although it's still read a to b. And then a divided by b. And again, when we're talking about ratios, we would probably still say a to b in this case. So if I want to have the ratio comparing 1 and 2, I can write this as 1 to 2, 1 to 2, or 1 to 2. If I'm trying to compare more than two numbers, then I want to use the dot notation. So if I want to compare 3, 7, and 9, I would use dot because I can't really make a fraction out of the three numbers. Okay. A proportion is an equation stating that two ratios are equal. So it's basically an equation with a ratio on each side. Two sets of numbers are proportional if they use the same ratio. Now if I have the proportion a to b is equal to c to d, then I can write it, again, either as a fraction or as using the colons. Generally, when I'm talking about equations, I like to keep them as fractions just because that's what we're more used to dealing with. With the colons in there, it looks a little funny. Now, how to solve these things is we use what's called the cross products property, which says that if I have it a proportion, and so again, if a over b is equal to c over d, and b and d do not equal 0 because we can't divide by 0, then I can multiply a times d, and that's equal to c times b. So I write it out that way, and then I can solve for my answer. One of the biggest mistakes that I see students make when we do cross multiplying is they forget the equal sign. And so especially when we start dealing with more complex proportions, it's really important that you remember where your equal sign is. So notice here we did the multiplication here, but we still kept that equal sign in the middle. That kind of lets us know where our wall is, where we're trying to move things back and forth across. So don't lose that. So to solve problems with ratios, generally you want to set up a proportion and then end up cross multiplying. So for example, the student-faculty ratio at a college is 15 to 1. If there are 500 faculty, how many students are there? All right, so we first want to identify what things we're talking about here. So we've got students, and then we've got faculty. Okay, so setting up my proportions, then I'm going to have 500 faculty is what I know, and how many students is what I'm trying to figure out. It's usually easier, although I guess when you're cross multiplying, it doesn't really matter a whole lot. But I usually like to put my x's on top. Just again, it just looks better to me. But you can work it either way. So students to faculty is 15 to 1, and so 15 over 1 is equal to 5x over 500. I cross multiply and I get 1x, or just x, is equal to 15 times 500, which is 7,500 students. Now, if you've got a ratio comparing more than two numbers, remember we talked about we can use the dots to compare more than two numbers. You usually want to, if we're comparing them, that means that they have something, there's some sort of common factor that they have. So we're going to let x be that common factor and set up an equation to solve for x. And then once we know x, then we can plug it back in and then find the original quantities. For example, let's say that I've got a triangle, and the ratio of the side lengths of a triangle is 2 to 3 to 5. That means that they could be 2 feet, 3 feet, 5 feet. They could be 4 feet, 6 feet, 10 feet. They could be any number of numbers with the common ratio being some number that ends up being with 2 to 3 to 5 is my ratio. Anyway, and its perimeter is 80 feet. What are the lengths of each side? Well, I'm going to let x be whatever that common factor is. And so my lengths are going to be 2x, 3x, and 5x. Well, the perimeter is all the sides added together. So 2x plus 3x plus 5x has to equal to 80 feet, which is my perimeter. Combine my like terms. I get 10x is equal to 80, which means that x is going to be 8. Okay, so now if I want to find the side lengths, I can plug it back in and say that means that I'm going to have one side that's 16, one side is 24, and the other side is going to be 40. And if you want to, you can check that and add them up, and it will equal to 80 feet. Okay, so solving each proportion. Again, these we're going to cross multiply and then solve the equation that we end up getting. So I've got here 3 over 8 is equal to x over 32, which means that I'm going to do x times 8 is equal to 3 times 32, which means that 8x is equal to 96. 96 divided by 8 would be 12. Okay, number 2, I'm going to have 2 times x is equal to 4 times 5. 2x is equal to 20, which means x is going to be 10. Number 3 is a little bit more complicated, but we're going to do the same thing. We're going to take 6 times x minus 2, and that's going to be equal to 3 times x. Okay, or the other way around. Now, use my distributive property here to clean this thing up. And so I've got 3x is equal to 6x minus 12. And then subtract my 6x from both sides. And I get negative 3x is equal to negative 12. We'll divide by negative 3, and I get x is going to be equal to 4. So I have the ratio of the angles of a triangle is 2 to 2 to 5. What is the measure of each angle? Well, unlike the perimeter problem, we don't have a number to set this equal to, but we should by now know that the angles of a triangle add up to 180, so that's how I'm going to set up my proportion. So 2x plus 5x is equal to 180. Combine my like terms, so 9x is equal to 180, which means x is going to be 20. I plug that in, and so I end up with one angle is 40, the other angle is 40, and then the third angle is going to be 100. Okay, so I have a 60-meter steel pole, and it's cut into 2 parts in the ratio of 11 to 4. How much longer is the longer part than the shorter? Okay, well again, I know that the pieces of my pole have to add up to 60. So that's how I'm going to set up my ratio. So 11x plus 4s equals 60. Combine like terms. So my common ratio is going to be 4, which means that one piece is going to be 44 meters. The other piece is going to be 16 meters, which means that the longer part is 28 meters longer than the shorter part. Now, what you also could have done here, once you found out what your common ratio was, you can say, well, 11 minus 4 is going to be 7. 7 times 4 is going to be 28. So that's going to be the difference between these two things. So you could have worked it that way as well. Okay, find the ratio of x to y for these two problems. Now, this is a little bit different because we're not going to come up necessarily with a number. We're trying to put a ratio of x to y. Instead of solving for x or anything like that, we're going to end up with x over y on one side of the equation and then some number or expression on the other side of the equation. So if 2x is equal to 3y, I want to end up with y on one side and numbers on the other side. Okay, so I'm going to divide by both sides by y. Okay, but I'm also going to divide both sides by 2 because I want to get rid of the y on this side and I want to get rid of the 2 on this side. Okay, so I end up with the 2's cancel out on the left-hand side and the y's cancel out on the right-hand side, and so I end up with x over y, or the ratio of x to y, is 3 to 2, or 1.5, however you want to say that. Okay, so this one here, again, a little bit more complicated, but we're doing the same idea. First we're going to distribute, and then we're going to get subtract 18 from both sides, which happens to cancel out the other 18. And so I have 6y is equal to 2x. Again, I want to have x divided by y. So I'm going to divide both sides by y, and I'm going to divide both sides by 2. So I'm going to divide basically this by 2y, this by 2y. So I end up with x over y is equal to 6 divided by 2, which is going to be 3. Okay, similar polygons. Similar polygons basically have their corresponding angles are congruent and their corresponding side lengths are proportional. So I've got these two trapezoids here, and the angles are all congruent. The sides are all have the same ratio, so 3/6 equals 4/8, etc. So the way I write a similarity statement is kind of like when we were doing a congruent statement, which was we put we list the corresponding vertices, and that tells us the way things would match up. Now the difference between the congruent statement and a similarity statement is the little symbol in the middle. This little symbol here means similar. It says that NOEL is similar to XMAS. So that's the only difference. It says they're not congruent, but this says they're similar. They have the same shape. Now if you're trying to check whether two ratios are equal, you can cross multiply them and the product should be equal. For example, is 3/6 equal to 4/8? Well, one way you can do this is to reduce both fractions, and you should get 1/2. Another way is to cross multiply, and you get 24 equal to 24, which is correct. Okay, so determine whether the rectangles are similar. If so, write the similarity statement and the similarity ratio. Okay, well first off, the statement that these are rectangles, that tells me that all the angles are right angles, so I don't have to worry about them. I know all of my angles are congruent. So next thing I want to do is I want to check my ratio. So I need to know is 6/10 equal to 15/25? Okay, so I checked that well. Again, I'm going to do my cross multiplication. So 6 times 25 is equal to 10 times 15. 150 is equal to 150. So yay, they are similar. And so my similarity statement would be some arrangement of quad is similar to RECT. And my similarity ratio, I'm going to take the ratio between the two rectangles and then reduce my fractions. So 6/10 or 15/25, either one of those. And reduce that and you get 3/5.